Hello and welcome to our webinar about global initialization through manual training. My name is Michael and I am the CTO of Visometry. Before we begin, as always, we are recording this webinar. This way you will be able to watch it again afterwards and share it with your colleagues maybe. We will have time for questions at the end of this presentation. If at any point during the presentation you have any question, just post them in the chat. We have made sure that this works this time, and we will try to answer every question after the presentation. So we as Visometry are a team of 30 tech enthusiasts and experts in different fields related to augmented reality. At the moment, we have two main areas in which we are active. On the one hand, there's VisionLib, our object tracking library, which most of you probably know. On the other hand, we developed Twin, an AR-based quality inspection tool. In this webinar, we will focus on VisionLib. More precisely, on global initialization through manual training. So this webinar will be similar to the last webinar. I will show you lots of examples and also some code snippets. It is structured in three parts: the manual training, where we start with a feature that you are already using to reinitialize tracking when it's lost. I then show you how you can store that data in a file and what parameters influence the training. Finally, I will talk about the possibilities to transfer the trained data to similar cases. In the next section, I will show you how to load that previously stored data and which parameters influence the initialization. We will extend on the previously learned data and deploy the result together with our application. In the last section, I will talk about the relationship between init data and the multi-model tracking and show you which commands exist to interact with the init data. So let's start with the first step: training the init data. VisionLib by default collects init data, so-called init data templates, to reinitialize tracking if it is lost, or to realign while tracking is critical. You can see that behavior in this video where it is able, which you can, we'll wait a second. Now I turn the camera away. And once the car is visible again, after it's not occluded by my hand, tracking snaps right back when it's no longer covered by the hand. This is very helpful on its own, but we still have to manually align the model with a physical car at least once in each tracking session. Now, what if you could store that state of the application and load it later, thereby saving your users from performing the manual alignment at all? This is what I'll do now. Again, I'll start the scene and train the data. As you can see here, on the left side, there's a counter of number of templates, which counts up. And I'll move the camera around a bit again to collect those templates. And once I'm done, I click on Write Init Data. And then the dynamic templates, the one learned during the reinitialization, are written to a file which can be loaded later on. You can see here that also when I click that button, the number of static templates increased, but the number of dynamic templates switched to 0 now. And once I clicked on Write, it created this file. So I shortly mentioned the dynamic and static number of templates. There are actually three numbers involved here. The total number of templates, which is just the sum of the values below. And those are all that are used for initialization or for realignment. The number of dynamic templates, these are the ones that are currently recorded and have not yet been written to a file. And the number of static templates that have either been written to a file or loaded from one. It is also possible to register to the on-tracking states event that tells you the current number of templates, since they are part of the tracking state. And you can react to that state, for example, by writing the init data, if, say, enough templates for your case are present. That would look like this. And I will now expand on what has enough templates could look like. In this case, I defined a number of 50 templates. And I say if my main anchor has at least this number of templates, then it's enough for writing them down to file. So now let's take a look at how to influence the learning, more precisely the density of viewpoints being set for initialization. This density is governed by the keyframe distance, which I will change now in the tracking parameters section of the tracking anchor, where you can change it by this slider here. And as soon as we track from a position that is at least so many millimeters away from any of the other viewpoints that we already have created an initialization template for, we will create a new one. So at the beginning of this video, I'll jump back to the start. You can see that there are not very many templates collected, while we are still using the default value for it. So I didn't move the camera very much, and we only created like three keyframes. But since when I move it down to 0.08 millimeters min distance, then it will collect almost every frame here. Okay, so next I want to say a word. Wait a second, did I miss something? Oh, no, okay. Next I want to say a word about transferability. It is possible to use init data. Let me start the video while I'm talking. It is possible to use init data created for one model with one that has a slightly different appearance, as long as they still have the same geometry. It is also possible to place the object in a different environment and still initialize with the same init data. So you can see here, I collected some templates and also wrote them. There are little overviews here. And now I try to initialize that on my desk with that init data. Wait a second. And it should also initialize once I loaded it. Yeah, and it directly snapped in. Let's go back a little bit to see what happened here, because that was a little bit fast. You can see that in this state, there are no templates at all loaded. And once I click on read init data, you will see that the number of static templates will jump up. And once this happens, so right now, I jump back. Then once the number of static templates jumped up again by reading that file actually to 76, it initialized with that car directly. So here again, once I read the init data, it initialized. What you can also see here a little bit is that if you don't assume a viewpoint where you already have collected some template for, like at least roughly the same viewpoint, it is not able to initialize. Okay, so it is even possible to use init data recorded on one device family on a different one, as long as the focal length and the camera of that camera does not vary too much. We did this with our companion app, where we trained init data for this Christmas mug on an Android phone and deployed that to both Android and iOS devices. Get that here. Okay, so now how can we now load the data that we persisted earlier to initialize tracking from positions that are not just the init pose? You already saw that a little bit hinted at, but I just clicked the button in the model tracking setup scene. But how could we do that programmatically? That's just this one line, actually. There's the init data handler component, and if you put a component that you write your own onto the same game object, you can just call the read init data function when the tracker has been initialized. It can also happen, like if you are still using .vl files, you can just set the init data URI in your .vl file, and that will work just as fine. For instance, if you are also using VisionLib in the native SDK, that is also a way to achieve that. You could also use the read init data command for doing that, but you can look that up in the documentation. So when we want to initialize using that data, we can fine-tune that behavior by setting the detection threshold or min init quality in the .vl file. It defines the minimum required overlap between model and real-world object that needs to be achieved in order to start tracking from. In the value that we selected here, if the value that we select here is too small, which I will do now, so the default value is 0.6, and if I turn it down all the way to, say, 0.19, it will try to track the mini car, on my keyboard as well. That is something that can happen if you choose a too small value for that. So I turn it up again. And then, as you can see, it understands that it's not there. Once it's one time, it also found it at my screen, but then it worked just fine. So if I turn it a little bit further up, it's not recognized at the screen anymore, just where the car is. Yeah. So let's go to the next slide. There's nothing else here. The second parameter that I want to introduce you to is not part of the parameters that are exposed in the tracking anchor by default. So I added it to the custom parameters list and to set it to false, because the default value of that learn templates parameter is true, actually. Since I now set it to false, we can still load static templates, but we don't learn any new dynamic ones. So that was a little bit fast, I guess. We'll go back here. So as you can see, the number of static templates is 48. After I hit read init data. Yeah, I didn't open it before. Okay, so it's 48 because like 48 templates are included in the .bin set file that we read. But the number of templates dynamic does not go up. If this parameter is set to true, which again is the default value, we can actually continue learning templates once we started a new sequence. Here we read the init data, which result in having some static templates. It also immediately starts tracking with that init data, and we can then collect some more dynamic templates. So 71 static templates here, and I now have 5 dynamic templates. Sorry, I resetted it. Probably the example was the interesting part happens here. So we have 48, and that goes up. And if I now write it, they both are combined into the static ones, and those are then written into a file. And what I did in the end is when I hit reset init data, it clears both containers, the dynamic ones and the static ones. Okay. Wait a second. So once you recorded a set of init data templates, you also want to ship it together with your application. To do so, you can store the .bin set files anywhere inside the streaming asset folder, as you can do by setting the init data URI field of the init data helper, which I did here. Yeah, you can see I set that to streaming assets dir column init data.bin set. And you can also record that on a mobile device. and store the init data to the local storage tier first, and then copy it from there to the streaming assets tier of the project that you want to deploy in the end. In this case, I just set the init data handler URI directly to streaming assets tier and record it inside the editor. Yeah, okay. And here's the init data underscore tracked object.binset file that was created in the streaming assets directory. As you can see, the file is not just named initdata.binset. I will tell you the reason for this in the next section. The details. Since release 3.1, the model tracking setup scene uses multi-model tracking. That means that it has a tracking anchor, which is named tracked object. In this example, I now created 2 tracking anchor components instead and wrote init data, still with the init data URI being set to initdata.binset. And as you can see, 2 files are created in this case. We append underscore anchor name to that file between the file name and the .binset extension. This happens both when reading and when writing the init data, so you can just use the same URI in both cases. Now let me sum up what happens when you send one of the commands that interact with the init data. I think I shortly mentioned almost all of them, but now we have a complete picture of that. Init data is used for reinitialization during the state lost and for realignment while in state critical. While tracking, init data is collected as dynamic templates. If you call the reset hard command, we reset the tracking and force a switch to the state lost, and it also clears the dynamic templates. The reasoning is that a user might have collected incorrect data for reinitialization when tracking was not behaving correctly, so that reset hard gets you in a known safe state. If you call reset init data, we clear both the dynamic and the static templates, but don't do anything else. If you call read init data, it reads the file and appends it to the static templates. And if you call write init data, we first merge the dynamic templates with the static templates and then write the result into the file name that you supplied. Okay, so what should you take away from this webinar is that and how init data is learned for reinitialization by default and allows for reinitialization when tracking is lost. It can be stored in a file and be used later on, and it can be transferred to different scenes and devices where the same object can be used. So thank you for your attention, first of all. And do you have any questions that have not yet been answered? The first question, okay, the chat does work. Cool. I'm very relieved. Okay, which is the first version of VisionLib that supports init data for multi-model tracking? I think that it was possible to be used like from the get-go. There might have been some hiccups in between, but at least with 3.0, it was usable with multi-model tracking, and also I think the behavior didn't change since then. Yeah. You said templates can be transferred, but is it robust to lighting conditions change? Good question. So it depends a little bit. What we extract from the image is like our edge information only for this as well. So if those don't change due to the change of lighting, then it's fine. And it's also more like the orientation of the gradients that we extract. So if it's not like stark lighting versus completely ambient, then it's, I guess, fine as well. Yeah. So it's designed to do so with limits, but it should work. Is it working with your HoloLens 2 or Magic Leap 2 implementations? Yes. There's no like inherent, the feature is enabled. For the Magic Leap 2, it also is, I think it's very good to use it there. For the HoloLens 2, I would suggest to use a higher keyframe distance, because and only to collect a couple of, or to collect less templates, because the algorithm is more performant if you only collect a couple of templates. And the HoloLens 2 has very limited computation capability. So if you keep that in mind, I think you should be good to use it there. Since this was our final webinar in this mini-series, please let us know if you liked it or not, or what you want to hear more about. And if you come up with questions while using init data, just send a mail to the support. And here would be my personal email address. So thank you again, and goodbye.